as we go on and talk about permutations, it's important to go back to the idea of factorial. And I just talked about it when we looked at the word July. But we talked about factorial being, say, the number 4 is 4 times 3 times 2 times 1. That's it. 4 factorial. Now this is true for any number. So if we had n factorial is n times n minus 1 times n minus 2 times n minus 3, and you keep going all the way till you get to times 3 times 2 times 1, and then you're going to get your n factorials do here as you did up here. It is important to know that 0 factorial equals 1, okay? It's very, very important to know that 0 factorial equals 1. It's not 0. I know that's odd, but it is important as we do some calculations to know this. So permutations. Now, this is true if I have say 5 objects and I want to see all the arrangements of those 5 objects, right? Or as we did with the word July or ABC. But sometimes you don't want all of those 5 objects. Sometimes you just want to take 3 at a time or 2 at a time. And I'm going to look at an example of that. When you do that, there's a specific equation for permutations. So permutations is P. This is for n objects. There's the n taken and r at a time. Okay, so this is for n objects. This is the number of objects. This is taken r at a time. Okay, and let me just give you the formula and we'll work it out. So this formula is n factorial divided by n minus r factorial. Okay, so if I was talking about my 4 objects, right, taken 4 at a time, I have, for example, and I'm going to write it smaller just because I don't want to take up a lot of space. My 4 objects taken 4 at a time is going to be P 4 equals 4 factorial, which you can see is up here, and we already calculated was 24, divided by 4 minus 4 factorial. Well, this means I have 24, right? 4 times 3 times 2 times 1 over 0 factorial. And we know from up here that 0 factorial is just 1, so is 24. In other words, and this just shows that it works in any situation. In this situation, if I'm doing the letters for July, all the different combinations, if I'm taking all 4 of those letters, I'm going to have 24, sorry, permutations, not combinations. I'm going to have 24 different permutations. Now I'm going to look for a situation where I have fewer than that. So you have a band, excuse me, and you've written 12 songs. Okay, so you have 12 songs that you have written, but you can only record 9 of them on the CD, okay? And this is, by the way, example 2, if you want to look at it later in the book. In how many ways can you arrange these songs on a CD if you're picking 9 at a time? So here is I'm just going to use my equation, P, and I have 12 songs. These objects are currently songs, and I'm recording 9, taking r at a time, so 9 equal to 12 factorial and 12 minus 9 factorial. And that equals 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3. I'm barely going to fit times 2 times 1. Divided by 12 minus 9 is 3 factorial, right? And 3 factorial is going to be 3 times 2 times 1. And just so I've made that note that this is going to be 3 factorial, and therefore 3 times 2 times 1. Once you've done that, you can see that you can cancel the 3's, and you can cancel the 2's, and you can cancel the 1's. And when you do the calculation, it is always staggering how high the number is. The permutations, the number of ways you can arrange those 12 songs if you pick 9 at a time, is 1,833,600. Permutations get big very, very fast. Now, another way to look at this, by the way, this equation, and for why it works, is simply speaking, when the same way we did the selection for July, right? When we're looking at these songs, and once you pick the first song, right, for your CD, and you have a choice of 12 for the first song, then you have a choice of 11 for the second song, and then the choice of 10 for the third song, and a choice of 9 for the fourth, 8 for the fifth, 7th for the 6th, 6th for the 7th, 5th for the 8th, and 4 for the 9th. And so really, truly, you could just see, you could even just calculate it knowing that I have the choice of 12 for the first song, 11 for the second, 10 for the 9th, etc. And you could still calculate that number if you can understand how you're selecting these songs. But this formula works easily and quickly in any situation. Okay, I'm going to stop here with example 2 because these videos get too long, and I'm going to do the last example with a third video of this lesson.